Hi everybody. Just thought I would give you the brief rundown on implication charts. I'm going to do a quick example here. This is present state, and it's going to be A through G. And then we'll do next state with x equals 0 and x equal 1. And we'll do something involving, let's see now, BAE, BBAE. And then we'll do another one, FD, FB, CGF. Then we'll do our outputs for x equals 0 and x equal 1. And it'll be 0, 0, 1, 1, 0, 1, 1. And then we'll do another output when x is equal to 1. It'll be 1, 1, 0, 0, 1, 0, 0. And we'll draw our lines to make it nice. And what I'd like to do is I'm going to group outputs that are similar together. That's why we left a little space in there. I'll call that a pedagogical trick. So now what I'd like to do is come up with an implication chart. I start at B and work my way down to G. And then what I'll do is I'll start my way at A and work my way up to F. Now I'll make a lower triangular matrix. And then what I'll do is I'll trivially reduce anything that has different outputs. So A is different from C, D, F, and G. C, D, F, and G. B is different from C, D, F, and G. Oops. Then we have C is different from E, but it might be equivalent to F and G. D is different from E. F and G might be the same. So we have some trivial reductions in here. Now let's take a look at A to B. A to B will be equal if A equals B, and also FD. We take FD out here, and we take a look at FD. F and D is going to be equal if A equals B, so that's promising, and if B equals G. B equals G. So I check out BG, it's got an X, therefore this gets an X. And that's just what we'd expect. Let's take a look at some of these other ones. How about D and C? So we go to DC, we see it's BE, and also BF. Well, BF has got an X, so that's good. We can take it right out. How about this other one here, EF? EF is AB, that's good. And then it says CG. I look up CG. I don't know anything about it. Let's take a look at CG. So CG is EE, that sounds good, and FF. So C is equal to G. And that is that's pretty good. I like that. Now let's take a look at C and F. So we'll do well, we already looked at E and F. Let's see now. E and F. Could E be equal to F? Let's see. It is if C is equal to G. What else do we need? E will be equal to F if A is equal to B, but it's not. So we got to eliminate that one. How about B and F, or B and E? Let's do that. So for B and E, we have AB, and AB we know we can eliminate. How about AE? Well, let's take a look. AE is BB, that's pretty good. And then CF. And CF we don't know much about. Well, let's take a look at that CF. C to F is AE. AE depends on CF. And FG. We'll put FG in here. FG. We don't know much about FG, do we? Let's take a look at FG. That's AE. And we can put that in here. And it's also GF, which we can put over in here. So now it's pretty interesting, right? Because if we look at GF, it depends on GF, so we don't need to worry about that. But that AE, we look at that, and that depends on CF. When we look at CF, that depends on FG. So all of a sudden now, FG depends on AE, so it's very circular. I think we can claim that these things are equivalent, or at least point to an equivalence. So we have A is equivalent to E, which is good. We've got already C and G, but it looks like F is also equal to G, so we can just throw that in there. So now I have C equals G equals F. So we got that, C and G. I got A and E. I got, put that check in there, C and F, got that in there. And now let's look at some of the rest. How about D and G? So we go to DG, we see BE, BE's got an X, we throw the X in there right away. How about EG? EG is BE, BE's got an X, so we get an X in there, and this is what we're left with, a nice reduced state. Thank you.